Newton's first law is an object in motion stays in motion until another force acts upon it. When you push off a wall in streamline, you won't stop moving if no other force is acting on you, but a swimmer eventually stops moving because water is pushing against them. This resistance to movement is known as inertia. Newton's second law is force equals mass times acceleration. When you wear a suit that creates less drag, your mass will decrease and you will need to use less force to go the speed that you want. If you wear more drag, you will need to use more force to go the same speed as if you were not wearing drag. But weight does not equal mass, because mass is a property of matter, while weight is a force that arises from the interaction between mass and gravity. This is a free body diagram of a swimmer who has just gotten off a block. They are traveling in a straight line, but applying more force than water is applying on them. They are traveling at 5 meters per second squared. Newton's third law states that for every reaction there is an opposite reaction. When you go to flip turn into a wall, your feet hit the wall at a fast speed, which means you hit the wall with a large force. You push against the wall and the wall pushes against you, which causes you to travel back in the direction you came from. If we did not have these crosses on the walls of the pool, which create friction, we would not be able to go anywhere, because we would slip and fall every time we tried to push off of a wall. Work is defined as force times distance. When a swimmer swims a distance of 25 meters with a force of 250 newtons, the total amount of work would be 6,250 joules.
Conservation of energy. The law of conservation of energy states that the total amount of energy of an object stays constant. During a backstroke start, you have a lot more potential energy right before the start than kinetic energy. When the buzzer goes off and you start moving, the potential energy of the projectile is converted into kinetic energy, but the total amount of energy stays the same throughout. Kinetic energy is energy associated with motion. A swimmer has more kinetic energy than potential energy when the swimmer is jumping off a block. Kinetic energy equals half times mass times velocity squared. Potential energy is energy associated with position. A swimmer would have more potential energy standing on the block than they would jumping off. Potential energy equals mass times gravity times height. Momentum. The formula for momentum is mass times velocity. When a swimmer does the running relay start, also known as the two-step start, you can calculate the swimmer's momentum by multiplying their mass by their speed. For example, the swimmer's mass is 59 kilograms and they jump off the block at a speed of 0.60 meters per second. That means that the momentum is 35.4 kilograms times meter squared.